we have a solid sphere. A sphere, if not mentioned, is a solid sphere. Rolls from a point A to B without slipping, that is pure rolling. And then after point B, it falls down. We need to find out the distance from this point, that is vertically below B, where the sphere falls. Now for solving this question, the first thing that comes to my mind when I see this question is that there are heights involved and velocities involved. Therefore, the first thing that comes to my mind is energy conservation. So in this question, we first try to see that whether we can apply energy conservation or not. So for applying energy conservation, there has to be two conditions. The work done by external forces should be 0, and the work done by internal non-conservative forces should be 0. Now since it is doing pure rolling, the work done by any friction over here will be 0, because the lowermost point is always at rest. Now the only work done by external forces can be due to work done by normal, which is again 0, because the normal is always perpendicular to the displacement. So we have already checked that the work done by external forces and the work done by internal non-conservative forces is 0. Under these two conditions, we can now apply mechanical energy conservation. People generally forget to apply these two conditions, but you should always check for these two conditions before applying mechanical energy conservation. So this states potential energy initial plus kinetic energy initial is equal to potential energy final plus kinetic energy final. So initial potential energy, let us assume potential energy to be 0 at this level for simplicity. Gravitational potential energy can be taken to be 0 at any preferable level. So we take gravitational potential energy to be 0 at this level. The initial potential energy can thus be written as mg into 1.4, this height being 1.4 meters. Initial kinetic energy was 0 because it starts rolling. Final potential energy is 0. Now we need to write down the final kinetic energy of the object. Now, this object sphere is doing combined rotation and translation motion. So in case of combined rotation and translation motion, we have a formula for the kinetic energy of the object. This object is in this situation over here. The formula for kinetic energy in case of combined rotation and translation is equal to half m VCM square plus half ICM omega square. In this formula, VCM is the velocity of the center of mass and ICM is the moment of inertia of the object about the center of mass, omega being the angular velocity of the object. So we apply this formula here, half into the mass m into v square plus half ICM. Moment of inertia of a solid sphere about its center is, about an axis passing through its center is 2 by 5 mr square. R is the radius of the sphere into omega square. Now omega can be written as V upon R because it is doing pure rolling. Therefore V is equal to omega R, omega is equal to V upon R. Omega square is equal to V square upon R square. This R square gets cancelled to give us the result mg into 1.4 is equal to V square mv square into 1 by 2 plus 1 by 5. M gets cancelled. We get V square is equal to 1.4 g into 10 by 7. This comes out to be 2g. Therefore, velocity is equal to root over 2g. So we get the velocity of this object at this point, that is equal to root over 2g. Now after this, it is a very simple question of projectile motion. This object has a velocity is equal to root over 2g in the horizontal direction and it falls. The initial velocity in the vertical direction was 0. The height is 1 meter. Therefore, we directly know that time is equal to root over 2h upon g. You should remember this formula and apply it directly. This is the time taken by an object to fall at distance h when its initial velocity is 0. So in the vertical direction, its initial velocity was 0. So the time taken will be equal to root over 2h by g is equal to 2 into 1 upon g, that is equal to root over 2 upon g. Now for the horizontal direction motion, the distance it will travel is equal to v into t, because the velocity in horizontal direction of the object will not change. So this is equal to root over 2g into root over 2 by g, that is equal to 2 meters. So final answer for the distance from C where this object lands is equal to 2 meters.